All right, so in this short lesson, we'll just go over the final homework problems for chapter 2.1. So let's start with number 18. Find constant a so that f prime of 1 equals 3. So this is just a problem on can you apply the product rule properly? So let's start with f prime of x. Differentiate the first equation, right? 3x squared, and then leave the other one alone. And then leave the first one alone. And differentiate the second one. So this is 3x squared plus 2x plus 1, and the constant goes to 0. All right, now we just have to plug in f of 1. So that's 3 times 5 plus 1 plus a times 6, which equals 3. So negative 12 divided by 6 is negative 2. 1 plus a equals negative 2. A equals negative 3. So that's pretty straightforward. All right, number 19, we have the function f of x here and polynomial function g of x. We don't know exactly what, but we have these two multiplying, and the tangent line, the slope of the tangent line at x equals negative 1 is minus 8. So we need to find the value of y prime. So that's going to be f prime of x, right? F prime of x gx plus g f of x g prime of x. Right, if we write that up, we need to use the chain rule on this guy, right? So it's going to be 2x minus k multiplied by the derivative of the inner function, but in this case it's just 1. And then x minus k squared g prime of x. Okay, and now we need to plug in x equals 1. So 2 times 1 minus k. G of 1 is 1. 1 minus k squared times negative 3, right, equals 8. And we have to solve this equation. All right, so let's expand this out. We have k squared minus 3k squared. We have minus 2k, so that's positive 6k minus 2k, so that's positive 4k. And we have minus 3 plus 2, so that's minus 1. And then we have minus 8. So minus 9 equals 0. So we have this quadratic equation. And we need, what? Is this it? Minus 3 plus 2 minus 1. 1, 3. Oh, it's negative 8. Oh, okay. Wait. So this is negative 8. So we have negative 3k squared, and then 6k minus 2k plus 4k, and then we have negative 1 plus 8, so that's plus 7 equals 0. All right, so we have 1 and 3, we need 4, so that's 7, 1, and we need positive 4, so the negative sign should be here. So k equals minus 1, or k equals 7 over 3. It says find positive number k, so k has to equal 7 over 3, so that would be our answer here. Right, just the combination of the product rule and chain rule. Just take it step by step and don't let that throw you off. All right, next on we have these two questions. Two functions, f of x equals x cubed 9x2, and this guy. So this is a and this is b, right? So here we need to first modify the expression. We have limit x goes to 1, f of x minus f of 1. Obviously, we would like to match this, and it matches pretty perfectly with the addition of this x plus 1 term when you factor the denominator, right? So this is going to be f prime of 1 times, this converges to 1/2. Now, f prime of x is going to be 3x squared plus 9. So f prime of 1 is going to be 12, and you multiply that by 1/2, so this is going to be 6. All right, so this one is a something that we've practiced a lot of times, right? So the denominator should be 1 plus 3h minus 1 equals 3h. So we need to have 3h in the denominator. And then let's go with the same numerator. 1 plus 3h minus g of 1 multiplied by 3 because we want to keep the original h, right? The coefficient was 1. And then this would be g prime of 1 times 3. So g prime of x would be 3x squared plus 4. So g prime of 1 would be 7. 7 times 3 equals 21. And find a plus b, so that's 21 plus 6, which equals 27. So that would be your answer for number 22. Number 24. We have a function and we have a single limit. So when we first look at the limit, it's the denominator goes to 0, but the limit exists. So the numerator goes to 0. So f of 1 must equal 5. And here we get one equation, right? So we get 2 plus a plus b has to equal 5. So a plus b has to equal 3. And then we go back to the limit and we can rewrite this as, hey, x minus 1 under f of x. And then we can substitute this for f of 1, so we can clearly see that this is the definition of f prime of 1 has to equal 8. Now taking f prime of x will be 6x, right? 6x cubed plus 2ax plus b, and f prime of 1 will be 6 plus 2a plus b, which has to equal 8. So 2a plus b equals 2. Now we got these two equations to solve for a and b. And let's subtract it. So a equals -1 and b equals 4, right? Yep, so find AB. So -1 times 4 is -4. So that would be your answer for 24, right? So the important lesson here is that you always want to go back to a limit and see you can extract an additional equation here. All right, so the final one is number 26. Now, those of you who've taken pre-calculus 12 would be more familiar on how to set up the situation for polynomial division, but let's take it step by step, right? So Rx be the remainder when this is divided by x plus 1 squared. Now, x to the 10 minus 3x squared plus 4, this would be divided by x plus 1 squared. Now, the quotient will be some sort of polynomial that we probably won't care much about, so I'm going to write this down as q of x. And then what's important is the remainder, right? So the remainder is r of x, but we can get a little bit more specific because the thing that we're dividing with is a quadratic. So the remainder should be at most a linear function. It can't have a matching degree or else we can divide, one more time, right? So let's set it as ax plus b. So that's going to be our r of x. Now, usually what you'll see is that you'll have two factors in here. You'll have like x plus 1 and x minus 2, and then you can plug in -1 and 2, and they will both make this mystery quotient vanish, so you can directly deal with these two and set up two equations for a and b. But this is not the case because this is a perfect square, right? So the best that we can do is plug in -1 and get 1 minus 3 plus 4 equals -a plus b. So b minus a equals 2, right? All we can get is that and not much else, right? So here's where differentiating becomes very, very handy, right? Because this is a polynomial division, we can plug in any value of x that we'd like. But what we can also do is we can differentiate both sides with x, right? So 10x to the power of 9 minus 6x, and the constant 4 goes away, which equals, right? This is a product rule scenario, right? So we're multiplying this and this. So let's use the chain rule to differentiate the first one. And then the derivative is just 1, so we don't need to multiply anything else. And then plus, we leave the first one alone and then differentiate the second one. Q prime of x, right? Okay, and then here the derivative is going to be a. So we're left with a new equation. And here when we plug in x equals -1, I should mention, when we plug in x equals -1, all these terms immediately go away, leaving us with another equation that we can use. So a has to be equal to 10 minus 6, which is 4. So therefore, b is equal to 2 plus 4, which is 6. Find r1/2. So r1/2 is going to be ax plus b. So 4 times 1/2 plus 6, which equals so plug in x equals -1. So we got a minus a plus b equals 2, and plug in x equals -1, -10. Oh, sorry, I just made a little mistake here. So a is not equal to 4 because this is to the power of 9, right? So this is -10, and this is plus 6, so this is going to be equal to -4. Okay, so a equals -4, that means b equals -2, right? Okay, so ax plus b equals 4x minus -4x minus 2. So r of 1/2 will equal -4 times 1/2 minus 2, which equals -4. So that would be your answer here. So taking the derivative and getting one more piece of information is way better than trying to do, polynomial long division with that and that, right? So that would be a interesting application of the derivative in a place where you would not necessarily expect the derivative to be much helpful, right? It's polynomial division, but the fact that you have this one new tool in your toolkit will help you a lot in these like seemingly non-calculus related problems, okay? So that was the end of chapter 2.1. So in the next lesson, we'll really get into the first set of applications for the derivative. So I'll see you there. All right, goodbye.